Hi, and welcome to Q's Workshop. Today I'm starting a short video series on building a oscillating or wobbler engine. So I've been keeping an eye on Ade Swash's YouTube channel for quite some time now, and he's got this one that he's designed called a WigWag engine. So he's got different variants of this. So he's got a mini version, a standard version. He's got doubles, triples, V8 versions that he's busy with. So it's well worth taking a look at his channel on what he's doing there. But I've decided just to start simple. So I've just got a single WigWag, and he's got all the build notes for it, designs in metric and imperial. So if you want to build along or build one of your own, go take a look at Ade's YouTube channel. There are obviously different variants out there. Some machinist handbooks have them in. I see Quinn over at Blondie Hacks is busy with one that she's designed. So yeah, there are various versions out there, but I'm just going to be doing this one from Ade Swash. The parts list, I'll pop it up in the corner. I've gathered all the parts that's needed for it. Some pieces, like these two pieces, all the pieces of brass and the bronze is longer than what's needed, but as I make my parts, I'll cut them off. But I've got everything. The biggest difference is the flywheel. So the parts list calls for a brass flywheel, but the size of brass needed, the 70mm diameter, it's pretty pricey to get a piece of brass that size, especially because you have to order it in a certain weight size. So it was just way too pricey. But I had this piece of 70mm mild steel in my scrap bin, so I'm going to be using that to create my flywheel. There's actually a video on Ade's channel regarding the weight differences between mild steel, brass, and aluminium flywheels, and it's quite interesting. So he does some tests on 3 different flywheels, so using a Baker fan to add resistance to the WigWag engine, and then obviously test the effects that weight difference has on the engine. So what I'm going to be doing is I'm going to build or make mine out of mild steel, my flywheel, and I'll just try and make it a little bit bigger or a little bit wider to match the weight closely to what the brass flywheel would have been. So luckily from that video I've got the weight differences, so I'll try and match my mild steel flywheel closer to the weight of a brass. So yeah, the only other difference is spring. I couldn't find a conical spring, so I've just got one of these straight normal springs. I've got a couple of different, let's say tension different springs. So if this one doesn't work, I've got a lower tension or a higher tension or compression rate ratio springs. So I can swap that out. And then the parts list calls for brass tube for the intake and exhaust. I didn't have brass tube and kind of buy it in long lengths, but what I did have is old MIG welding tips. So these are copper MIG welding tips. So all I did is I drilled out the clogged holes in them to 3mm, and I'll be using these. So they are tapped on the ends. So all I'll do is the mating part I'll drill and tap and then screw these in. But that's the only differences. Everything else is exactly the same. But yeah, stick around and let's get into it. Alright, so I'm going to be following the build notes and the drawings in the order that they provided. And first up is the column and the base. So there's just 2 adjustments that I've had to make. First is my column. The thickness of my column is 15mm, where the drawings are 12. And that I also need to consider when I'm looking at things like the bearings, the axle, and the pivot rod. those all make their way through the column, so I have to make an adjustment on the lengths of those to accommodate that additional 3 millimeters. And the base itself, my base is 100 millimeters wide, not 80. And that, I guess, it doesn't change anything on any of the other parts besides where the holes are drilled. Right, we're over by the mill now. So I've done some layout on the part. This is purely as a reference, visual references for myself. I'm going to be using the DRO on this part anyway. So I've got the edge finder in. I've got 2 reference edges which I've actually made these layouts from, so I've just marked those as my reference edges, that if I do turn the part, it's a very simple part, so it's probably just going to be one operation, then I'm done, but I marked them anyway. I've then, on my vise, I've written down what the operations are going to be, so I've just got my points of reference for the DRO that I'm going to be looking for. I've already taken into consideration the radius of my edge finder, because I need to move over the radius of the edge finder to get the true 0 point of the 2 sides. And then it's going to be simple. I'm going to go down with a 5 millimeter drill, which is meant to be a clearance for the M5 screw. So once I go in, I'm going to check if that hole is big enough for the M5 screw. If not, I'll use a bit of a bigger drill. But generally, these drills cut oversize anyway, so it might actually fit that M5 screw. Then I need to do a counter bore for the head of the screw. So I'm going to just lightly drill in just under the point of this drill, just to get a starter hole. Then I'm going to come in with a 9 millimeter end mill that I can actually get a flat bottom on it. And that's just for the countersink or counter bore for the head of that screw. So yeah, let's get on that. Okay, just going to get the 9 millimeter in here for the counter bore. I'm just going to create some chamfers on the side of the top piece of the base plate, just to make it look nice. So I've already found the edge on it, and now it's just to cut the profile. That's all the chamfers cut. Right, so I've got the column in the vise now. I'm going to do the same beginning operations as others. So I'm going to zero on the sides. I've already got my measurements written out on my vise. I've added the 2.5 for the radius thickness of my edge finder, just to accommodate that. I can also zero the mil, so I can move over 2.5, zero the mil, and then I don't have to add it, but I just added it there. The only difference that I'm going to do is on the drawings. So this is specifically sheet 2, which is the operation that I'm going to do now, is the 2 holes over there. What I'm also going to do while I'm in this setup, I'm actually going to go to sheet 7 and I'm going to drill out the exhaust and input ports, because those need to be on a radius of 12 from the hole that I'm already going to drill. So from this pivot point, it needs to be on a radius of 12 degrees. So once I've drilled my pivot center, I'm then going to use the DRO to get the 12-degree radius and actually drill those 2 holes, which is the inlet and exhaust. It's just going to be easier while I'm in this setup to actually get those drilled out. So that's the only difference, is I'm just going to do those 2 while I'm in the setup. All right, so let's find the edge and get going. Okay, so I've got a 8mm drill in, but what I'm going to do is I'm going to do these holes the same as kind of the counter sinking or counter boring on the base. I'm just going to go in just below the surface with the drill, and then I'm going to follow that with an 8mm end mill. I think that's going to give me, firstly, the best surface finish, because I don't have a reamer. It's going to be a good finish in there, but it would potentially be a little bit more accurate using the end mill to plunge rather than the drill. And these are center cutting end mills. Right, just to our cut. So next is just the inlet and exhaust port. Okay, so I've now zeroed on the 0 point of the pivot point, or the pivot axis over there. So it's zeroed. I've set the DRO to a diameter of 24 because I'm using the circle drill pattern. So I've got it on 24, radius is 12. I only want to drill 2 holes, so I've set it to 2 holes, and I've worked out the degrees of where the hole needs to be is 15 degrees. So my first hole gets drilled on 15 degrees and my last hole gets drilled on 345 degrees. So I'm first going to center drill it with a mini center drill, and then I'm going to drill it to 2.5 millimeters. Okay, those are done. So next up is the mounting holes on the bottom piece here. So I'm going to get this stood upright, that we can actually get those 2 holes cut in. I made a little mistake here on top while cleaning the surface up, but I'll take a look at it's only 3mm, so if it looks on the drawings, it looks like there's enough material on top here, so when I clean up the edges and things, I might just take that 3mm off. I'll take a look at if there is enough allowance for that. Right, next up is the mounting holes on the bottom. So I've already done my edge finding. I've written down the coordinates for the DRO. I'm first going to center drill it, and then I'm going to drill it for M5 tap. It is standing out quite a bit, so I'm just going to take it nice and easy. That's it. So this will just get tapped M5. Alright, so I'm busy drilling the inlet and exhaust ports for the tubes to fit into. So all that I did is I just manually measured where these holes are sitting, and then I'm just drilling the holes in the top that intersect that. So the inlet then will intersect the small hole on the face. So I just measured that and then punched the top. It was just easier than trying to work out the dimension of where that's sitting. So I drilled it out now to a 4mm. I'm just doing a 5mm that I can tap at M6 for the little exhaust pipes that I've got, which is the MIG welding copper tips that will sit as in this M6 then. Right, now on to the exhaust port on the side. So I'm just going to flip everything and then lower the coil down that I can get there. That will screw one there and one over there. Right, so the last piece is just cutting out the shape of the column. So I've changed it slightly. So the section here that's meant to be taken off is 10mm. So essentially you're left with a center section of 20mm. But because I'm using threaded holes for specifically the output, because it will affect the output the most, or the exhaust, I need a little bit more fat here on the side for that threading that I've got there. So what I'm going to do is instead of taking 10mm off here, I'm just going to take 7.5, and then I've just adjusted that angle over there to accommodate. So yeah, it's just scribed on here. I'm going to work towards those scribe lines. I mean, it's nothing serious overshooting that slightly, it's just the shape. Obviously in this section where the cylinder sits, I can't go too much in there, because that could affect the movement of the cylinder. But ultimately, as long as that face is nice and clean and big enough in this section here, it should be fine. So I'm just going to get this in the vise. I'm going to start off with the two sections here to remove those two pieces, and then I'll do the sloped section. Right, so I'm going to do the sloped edge now on the side. So what I've done is I'm using a parallel on the top of the vise, and then I'm ensuring that the line that I scribed is just showing above the parallel. So what I'm also going to do is I'm just going to bring my end mill down to that point. So it's just touching the parallel, and I'm going to zero my z-axis on that. So that's essentially as low down as I should be going, and I shouldn't come over too much, otherwise I'm going to start cutting into this flat section, which is now standing at an angle, so it's standing up. So it's standing like that now. So if I cut further than a certain point, I'm going to be cutting into this flat section. So I'll just be bringing it over. So I'm just eyeing the side of it. So I can take a scale as well and just put a scale against it, like that. And then I just want to make sure that I'm not coming further with my x-axis than that scale. So what I'll do is I'll zero my x-axis in line with that scale, so I must just make sure I don't go past the 0 point. And that's it. Just got a little bit of a burr there for cutting close to that section. Same over there. So I'll just clean those up, but looks good. Let me clean the two pieces up that I've done and get you over at the workbench. Right, I'm going to be closing the video off here. Made actually a lot of progress. I know I said I was going to work on the drawing sequentially, but actually doing the input and exhaust port holes on the face was just easier while I had the column already in the vise for the axle and the pivot point. And that's because from the pivot point there's a radius that you have to actually drill those holes. So while I had my center point on the pivot, it was just easier to use the DRO to actually find those points. So there was some calculation that I had to do on where they sit, but it was just a lot easier to do that. I did, however, make one mistake. So if you look here, the intersecting holes that I have to drill from the top and the side, I put on the wrong side. So the input's supposed to come on the right, and then the exhaust output, which is then going up, is supposed to come on the left. So mine is the wrong way around. I am, however, still going to keep the exhaust pointing to the top, and that's because my understanding of the exhaust being vertical is that any oil that goes out of the exhaust, gravity will pull the oil back in and lubricate the face, so you're not then losing oil that's going vertically out the side. The only effect that should have is the little engine will run in the opposite direction. That's my understanding, but you can correct me in the comments if that's incorrect. But yeah, the sides, so this actual profile, I cleaned up a little bit here with a file, so there was a bit of a burr there. I didn't hit that dimension perfectly that the two met, so there was a little bit of a burr there. I just cleaned that up with a file. And I think the last one was, so originally I thought that my end mills that I used to plunge with, that they were both center cutting, but they weren't. Only the one for the pivot point was center cutting. So when I tried to cut the bottom halfway through, when I hit the depth of as far as I went down with the drill, obviously it didn't cut because it wasn't center cutting. So what it did is it actually moved and created a divot in the inside, almost like a mark in the inside where it was pushing to the one side. So I've had to change the diameter for the axle. So this is 14 millimeters now, but it's got a really clean cut in there, almost like it was done with a reamer. So all that I got to do is the bearing, I'm going to push up the outer diameter of the bearing. I'll push up to 14 millimeters. But that's it. I think that went really well and we made good progress. So in the next video, I'm going to be doing the cylinder. So be sure to keep your eye out for that one. But thanks for watching, and I'll catch you in the next one.